Okay, this is a graphical representation of the fixed point iteration method. So xn plus 1 equals gx to the n. Method only works if the gradient of g of x is between -1 and 1 around the root. And if you remember, rather than finding the root of f of x, we're finding the point of intersection of y equals x and y equals g of x. So the gradient of g of x needs to be shallower than the gradient of y equals x around the root, because y equals x has gradient 1. What happens with these diagrams is you start at your starting value. So I've put my starting value here, x0, and then I go up to y equals g of x, and then I go across to y equals x. So that's putting my g of x value into x. If you were to drop back down here, that's your next x value. So you could, in a sense, drop back down. That's x1, and then you plug that into g of x, across to y equals x, and down. So we don't bother writing in this bit, actually. But you're actually plugging in successive values of x. So you go starting value, y equals g of x, across to y equals x, up or down to y equals g of x, across to y equals x, up or down to y equals g of x, across to y equals x, up or down, across, and then you're homing in on that root, and that creates a staircase diagram. Here, so I'm going to put my x0, my starting point, over here. I'm going to do the same thing. This time the gradient of g of x is negative, but it's shallower than 1. So you're looking at a gradient between -1 and 0 around here. So start at x0, across to y equals x, up or down to y equals g of x, across to y equals x, up or down to g of x, across to y equals x, and now we're spiralling in to the root, and that is called a cobweb diagram. And so your successive x values will be, this one's bigger than the root, smaller than the root, bigger than the root, smaller than the root, and so on. So they'll fluctuate from being bigger and smaller than the root, but they're still converging in on the root. So the method fails if the gradient of g of x is greater than or equal to 1 or less than or equal to -1. So there's a couple of examples on there. What happens now is that rather than moving towards it, you move away from it. So I can do exactly the same thing. If I start here, I go up to g of x, across to y equals x, up or down to g of x, across to y equals x, up or down to g of x, across to y equals x. And I'm moving away from this root that I was trying to find. It may be that you'll converge into a different root somewhere else, but I'm certainly not getting anywhere near this root here. So it's stepping away from the root. Here I've got a negative gradient that is smaller than -1, and doing the same thing. So I'm going to go up to g of x, across to y equals x, up to g of x, across to y equals x, up or down, this time it's going to be down to g of x, across to y equals x, and that is going to spiral away from the root. They're quite, you can put some arrows on if you want to, they're quite hard to draw because they tend to just spiral off the page quite quickly. So that's not converging in on that root, it's diverging away from it. And same thing here. So we're stepping away from the root. But you're meant to just be aware of these diagrams. So I just found one exercise on this actually. So if you could do that next, and it's in your lesson folder.